The vast majority of solutions we wind up dealing with are solid in liquid solutions. Again, like dissolves like to make a solution. So if I have a solute that's polar, we would expect it to be soluble in a polar solvent. If I have a solute that is nonpolar, we would expect it to be soluble in a nonpolar solvent. And then if I have something that's ionic, we would expect those to be soluble in polar solvents. Because remember, ionic compounds have a positive and negative ion. Our polar solvents, they're going to have a partial positive and a partial negative end with which to interact with the anion or the cation. All right, and we are replacing our solvent-solvent interactions and our solute-solute interactions with that solvent-solute interaction. Okay, and so that's why we have to have that like dissolves like. We have to have those similar forces in order to get things to interact with each other. All right, and so we get these, if it's in water, we get these spheres of hydration that are going to form around our particular solute particle. Okay, so ionic compounds, it's easy because we're just looking at ions. Okay. When we look at something like sugar, which is not an ionic compound, it's a covalent compound. We do get interactions between our water and our sugar because sugar has oxygen in it, okay? And so remember, with hydrogen bonds, for a hydrogen to participate in a hydrogen bond, it must be bonded to an oxygen, a nitrogen, or a fluorine. But for an oxygen, a nitrogen, or a fluorine to participate in a hydrogen bond, it just has to be present. It doesn't have to have a hydrogen on it. So if it's there, we can hydrogen bond, and sugar's got oxygen, so we can get some hydrogen bonding. And so that's part of what drives the solubility of sugar. Okay, so let's see here. Where are we going to get more dissolution? So sodium chloride. Should it be more soluble in methanol or propanol? So methanol is much smaller. Methanol is miscible with water. Propanol is a little bit larger. That's where we start to lose our miscibility with water. So should we get more solubility in methanol or propanol? We should get more solubility in methanol. Ethylene glycol. So ethylene glycol has a OH end, 2 carbons in the middle, and then another OH end. So we would expect that to be more soluble in hexane or water. Well, we do have a couple carbons there, but they're buffered on either side by those hydroxyl groups, which can hydrogen bond. There's no hydrogen bonding in hexane. So ethylene glycol, we would expect it to have more solubility in water. And then diethyl ether, okay? Diethyl ether has 2 carbons and an oxygen in the middle, and then 2 more carbons. Water, we know what water looks like, and then ethanol is 2 carbons with that hydroxyl. So ethanol is almost like half of a diethyl ether. So where do you expect to see better solubility for a diethyl ether, water or ethanol? Should be the ethanol, okay? And so when we start to look at different things and dissolve them, either liquid-liquid or solid in liquid, we have different things we have to consider. But the biggest thing, the biggest consideration to make is that like dissolves like. We need to have similar forces to get things to mix with each other.